All right. I think we should be live
Awesome.
soon.
Hello, everybody, or anybody who's jumped in here at the beginning of the stream.
All right. Yes, we are live. And we also got a thumbs up from the backstage. So we're definitely live. Hello, everyone. Welcome to our first session that we're doing on tracing for agentic AI pipelines. And I'm very happy to have John Gilhuly from Arize AI as our first guest talking about this topic for our channel. And without further ado, I think I will give this whole session a start. Before I get into the agenda, John, would you like to give a quick introduction to yourself?
Yeah, hi, great to meet everybody. I'm a developer advocate here at Arize, so focus on a lot of our own events that we do, go to a lot of our meetups and things like that, and then also get to spend a lot of time creating tutorials and different materials that we put out. So we've been thinking a lot about agents over the past few weeks. We're in the middle of our own agent series right now, so this is perfect timing, and excited to get into it.
All right. I'm going to act mainly as the host this time. This is my favorite kind of events because that means I can just sit back and listen to a new topic. But here's what we're going to do. So we're going to be talking about tracing and observability for agentic AI applications in general, like what that is, what we can learn from this process. And then hopefully we're also going to have a quick demo into how we can set up tracing for Haystack pipelines with Arize Phoenix, which is the open source tracing application that you can set up by Arize as well. We'll have some time for Q&A, and I just wanted to point out that hopefully if we set up everything right, any comment you add to this live stream we'll be able to see. So if you have any questions, do drop those in and we'll answer them at the end as well. For anyone who is not aware about what Haystack is our open source AI framework that allows you to build many AI applications, including agentic pipelines, and it comes with a whole bunch of components. And here you can see a very simple one that achieves a retrieval augmented generation pipeline. So we have a bunch of embedding components that can embed queries with different model providers, retrieval components that can interact with different vector stores, ways to design and customize your prompt or instruction, and so on. So as you can see, usually any AI application has multiple steps working together. And this is where tracing comes in, because we want to be able to make sure what's coming out of each step, whether we've done the right thing or not. We already have a Arize Phoenix integration. So this QR code will take you to our integration page on the Haystack website that gives you very simple instructions on how you can set up Arize Phoenix. You only have to provide a few lines of code, and by the end of it, hopefully you'll be able to see something like this, where you are able to trace all of the steps of your application, check what kind of documents were retrieved from your retriever, check what your prompt was at the end of the generation step or the augmentation step, and so on. But I'm not the pro when it comes to this, so I'm going to shut up now and I'm going to let John take the stage. So hold on, let me set that up, and hopefully you will be able to see your slides now. And
There we
yeah,
go.
the stage is yours, John.
Awesome. Well, thank you, Joanna. I really appreciate the intro there as well, too. It's been a fun integration that we worked on so far. So yeah, we're going to dive into observability and evaluation, tracing and evaluation, specifically for agentic applications. I've got some slides to kind of go through the conceptual piece of this. We'll talk about tracing, observability, evaluation, what it is, how you do it, some concepts there, and then I'll show an example that we have that goes pretty far into how you can set all that up within a Haystack pipeline. So I'll do a little bit of background here on Arize. I promise I'll keep this part pretty quick because we want to focus on the technical side of things here. But just to kind of contextualize who Arize is, where we're coming from, and the idea that we're trying to bring forward here. So if anyone's been developing AI applications, which I'm sure most of the audience has for the past year, you've probably run into this thing where if you build an application, you get it working, you suddenly start to see errors crop up in one area of the application, then you go to fix that error and you end up breaking something in a different part of the application. And so you can end up in this sort of game of whack-a-mole where you're trying to fix different issues that crop up, you're having regressions in different areas, and it just gets very difficult to kind of understand the performance of your application, where it's doing well and where it's doing poorly. especially as things keep changing as fast as they do. So that is one of kind of a few reasons that Arize tries to solve through observability. So that kind of issue of knowing the effects of making a change in your application and benchmarking the performance of your application as you make changes. It's also a lot around visibility and providing visibility into what's happening within your application so that you know what's going on there through each of the calls. Haystack does a really good job of making it easy to set up pipelines and chains and different components, but you want to be able to see exactly what's happening within those, and that's where observability can really help you out as well. There's more that we do around kind of monitoring and production and jailbreak protection, guardrails, and things like that that maybe we'll save for another time. But these are all kind of areas that we provide solutions in. I'm going to focus kind of more on the kind of earlier stages of this today, the tracing and evaluation pieces, but just know there's more that we could go into as well. And so when we talk about observability, I think some folks are probably familiar with the term. It's not an AI specific term. It's been around for a long time. But when we talk about observability in the context of AI and LLM applications, what I mean by that is kind of giving you full visibility into everything your application is doing and how it's performing at different steps. So if we kind of break this down into how we think about observability, it's a few different pillars here. It's providing you visibility into all the different calls that are being made. So your LLM traces and spans and viewing those. It's evaluation of different steps of your application. So giving you performance metrics for each of those different pieces. And then there's some tools to help you improve things over time. So once you have that baseline of traces and spans and then evaluation, also giving you the tools to improve on those and increase the performance that you're seeing from your application through prompting, through improving RAG systems, even through fine tuning or through improving your agentic system as well. So we kind of think about observability in those 5 kind of categories, and I'll talk more about each of those as we go forward here too. Last piece that I'll talk about is just, we're going to skip through some of these pieces because this is a little bit more on the pitching side, and I want to get more to the technical side because that's the more interesting thing I think for folks today. One thing that I'll talk here just briefly about is, as Tawana mentioned, we have Phoenix, which is our open source tool, and then we have Arize, which is a sort of an enterprise platform that does what Phoenix can do and beyond. That being said, Phoenix is not meant as kind of like a starter-ish kind of product or anything like that. It is really supposed to be a fully featured observability tool, and you guys will hopefully see that as we get into some of the demoing of it. And we're in a lot of brands. That's always the slide we have to show. Cool. So we'll start talking through observability in the context of tracing. So I'm going to start with going into tracing and spans and some of that data collection and telemetry collection. Then we'll talk a little bit more about evaluation specifically, and then jump into the demo from there. So within observability, I always just like to start with why this sort of matters. And so with observability, really, it's all about helping you take an application that you've created, maybe an MVP that you've created or a demo that you've created, and turn it into a really robust, production-ready, usable, scalable application. So it's giving you the tools that you need to make things kind of really work in production or just work beyond the initial few use cases that you have. And if you've been following a lot of the news stories around AI agents or just AI in general, we've been seeing a lot of these cases of new deployments with kind of big errors or big problems that will come up as folks try to use them. One of my favorites is the one on the top right here, which is the Chevy Tahoe kind of news story that happened at the end of last year, which was where someone was able to kind of prompt engineer in a way, or prompt sort of jailbreak a Chevy Tahoe chatbot on their website to sell them a car for $1. And you see stories like that kind of cropping up in all different places. And so part of this is evaluation, part of this is based on guardrails and kind of preventing bad inputs. But the general kind of theme here is that we're seeing this, as the technology develops, it's almost developing ahead of the tooling around it in some ways, especially when it comes to observability. And so observability is really what's going to help you prevent these sorts of situations from happening, and also just improve the application or the performance of your application as you go into market with that app. You guys have probably seen the sort of Gartner hype cycle chart that we have here. You could debate where we are on this the whole way for the rest of the session if we wanted to with regards to AI, but observability is, in my mind, something that brings us along to the right here, along with just time passing, but it's a tool that helps you move towards that kind of plateau of productivity as we continue moving forward with AI development. And I've mentioned the definition of observability a few times here, again, getting you that complete visibility into the different layers of what your software is doing. Within the space of AI and LLMs, that looks like giving you insight into your application calls, into the calls you're making to different LLMs, the prompts you're using, the responses you're getting back, your token usage, your cost, your latency, everything that's happening in each different step of your application. And then there's a couple other definitions that are helpful to know as we talk through this, tracing and spans, or traces and spans. When I talk about traces, what I mean by this is one full run through of your application. So if you've got a RAG pipeline, for example, that's going to be a user input all the way through to the output. So that full run through of your application. Same with an agent, it would be kind of an input into your agent all the way through to the final output of that agent for that given run. And then within that, you would have a bunch of spans, which are the individual calls or steps that your application goes through as part of that one full run through. So again, if you had a RAG pipeline, then the spans might be retrieving, like sort of generating an embedding for the text that came through, retrieving documents based on that, re-ranking documents if you're using a re-ranker, and then making the eventual call to an LLM to generate a response. It might also be in an agent, it would be execution of tools, it would be kind of other steps that your application goes through there. So you hear me say traces and spans a lot. Again, traces is the sort of the top level full run through, spans are the individual calls within that run through. I'll show you what this looks like in an example. I always like to just actually jump over to our Phoenix dashboard to show that. So this is a demo dashboard. Let me blow this up a little bit that we have. That is a demo pipeline here where we've got a RAG pipeline that's been set up, and we'll kind of show you what some of the traces look like. You know what, actually, I'm going to do a little bit of a preview here of what we're going to run through in a second, but I'll show you actually a different one here, which is some pipelines from the walkthrough we're going to do a little bit later on. But within this, I've got individual runs of an application here. These are individual runs of, in this case, a Haystack pipeline that we set up. So if I click into one of these, you'll see this whole thing here is one trace, but then you can see in this case, this is an agent with some tool handling and then an eventual RAG pipeline that gets called. And so you can see each of these cells here is one kind of step of our application or one span in our application. So if I click on our chat generator, you can see things like the system prompt that's being passed in, the user prompt that's coming through. We're tracking the token usage. We're tracking the sort of response that we get back from that particular token or that particular call. And then you might also, in this case, this is kind of a basic example you guys will see in the when we go through the code, but we've got some documents that are being retrieved. We've got just some basic documents in memory here. And you'll see there's some evaluation here, which I'll talk more about a little bit later on. So you can see the different pieces that are coming back. And basically, like I can say, okay, this is one run through of my application. I've got input and an output that's coming through here in that info and the eventual output that we have and the chat message that comes back here. And I can kind of go line by line and start debugging this if I want to, or span by span, and debug all the different pieces. So I might try to see if there's an issue with one step of my application. Maybe we're calling the wrong function from our agent router. Maybe we're not retrieving the right documents. But one of the really nice things about Haystack is that you can set something up like this in relatively few lines of code with a kind of basic structure to it pretty easily. But it does mean that it's sometimes hard to see what's happening under the surface. And so that's kind of like step 0 of observability, is just giving you that visibility into what's happening below the surface there. All right, cool. Just want to see if there's any comments as we go through. I think we're okay for now. Great. And so we'll come back to the dashboard in a minute here, but I'm going to keep going through our pipeline or through our slides. So showed a little bit of an example of what some of the traces look like, as well as the spans, and giving you some of that observability into what all those different steps are doing. And then I'll talk briefly about where some of this is coming from. We could go a lot deeper into kind of the background of observability generally and tracing and sort of the origins of it all. But just to kind of give you an idea, a lot of what we do is built on a framework called OpenTelemetry, which is kind of a long-standing, well, 7-8-year-old open source project that does telemetry and observability for lots of different kinds of software. So it's everything from networking, AI now, to all kinds of just regular software development. And we've essentially built on top of that to make our own kind of layer here that translates a lot of what is done in OpenTelemetry into more LLM specific calling. So we can kind of translate those OpenTelemetry standards into a more LLM specific version of that. And then what I showed you in that UI is the Phoenix kind of dashboard, which we then have as the sort of receiver of all of this information. So we generate a lot of information from our application using the OpenTelemetry and Open Inference, that layer that we have standards, and then we send them through to a collector or some sort of endpoint like Phoenix. And the reason I mention this is just because one, it's kind of fun to know and interesting to see that all of this is just sort of open source software that's been stacked on top of each other in different ways. So it's kind of open source all the way down, which I just like. I think that's a nice way to be developing software. And then the other piece I mentioned it for is that if you set up your application to be kind of instrumented, I'll talk about what that means in a second, with OpenTelemetry or with some sort of compatible standard, that gives you a lot of portability as you move between different tools. So Phoenix is awesome, and I think it really is the best observability solution in the market. But even if you were to set up your application with OpenTelemetry, you would be able to use multiple different observability solutions kind of easily. So kind of a pro tip there, but it's one of those things where you can set your application up in a way that's very portable to move across different solutions, and then even sending OpenTelemetry into non-AI specific observability solutions or other tooling that might be compatible with that underlying framework. And then I mentioned I kind of talked through pieces of this, but basically the way that a lot of traces end up getting captured is you have an application that you've instrumented. Again, we'll talk about what that looks like in a second. And then using OpenTelemetry, you can send those calls through to different tools that can process them or receive them. So that's generally how observability will work. And you guys will see with Phoenix, the way that we have it set up is you essentially run the Phoenix application either locally, you can self-host it, you can access it in the cloud. You run some instance of the application, instrument your application, that your sort of LLM application, to send through traces to that Phoenix instance. And that's how we can set up the whole pipeline to see some of that data that I just showed you. And so instrumentation is always an interesting one to talk about here. So what instrumentation refers to is basically the process by which you go through your application and mark all of the different calls or attributes or things that you want to trace and send over to whatever kind of observability platform you're using. What you're looking at on the left is sort of the manual way to do this with OpenTelemetry. So that right there, all of that is to set up OpenTelemetry, set up a basic connection, and then trace one LLM call with 4 attributes attached to it. So 4 pieces of info on one LLM call. So you can imagine that there's a lot of code that gets involved if you try to do all this manually. And so this is where one of the nice things that we provide is the integration that Joanna showed earlier, where we build integrations with different platforms to have these auto instrumenters, we call them, which will essentially go through and say, this bottom line that you see here on the right, what this is doing here is it's going to go through your Haystack package and essentially like wrap some of the calls in there, specifically the pipeline calls, in our own code to capture all the right information. So everything that you saw on the dashboard that we were looking at, that's all coming from just this one call. So you don't have to go through and manually mark all of the different things that you want to send through to your application. So if you were trying to kind of build observability yourself, which we've had some people look at before, you get ready to do a lot of what you're seeing over here on the left throughout your whole application versus just using one line here to do the instrumentation. And then I mentioned before, the nice thing about being standardized to OTel is that you can use it across multiple different kind of collector destinations. So a lot of observability tools are compatible with that OpenTelemetry framework. So if you stick tools that are compatible there, you can instrument once and then have your data in as many different kind of receivers as you want. So that becomes a very nice way to avoid any kind of lock-in to particular tools or frameworks. My open source side is coming through there. Awesome. And so then with that, I want to shift gears and talk about kind of the second piece of observability, which is more about evaluation. So once you have all that tracing and span data, how do you use it? How do you set up evaluation to actually measure that performance of your application, not just see what it's doing? That's where we get into evaluation. And so evaluation can be run on either full traces, so full run throughs of the application, or on individual spans. And so you could run it on just the retriever step of your RAG pipeline, or just the, say, function calling step of your agent. or you could run it on the full run through of your agent. You could do it at kind of whatever granularity you want to there. And then there are a few different kinds of evaluations, and I will caveat that the 3 categories you see here are sort of my own categorization of these. A lot of this is industry standard terms like LLM-as-a-judge, but grouping them in this way is something that I like to do because it sort of helps me think through how I'm going to approach evaluation. And that's splitting them into ground truth evaluation, LLM-as-a-judge evals, and then more kind of data analysis or data set analysis, kind of embedding visualizations and things I'll show you guys there. But you can run all these different types of evaluations through Phoenix or through other tools as well. And I'll talk about each of these. Your ground truth evals are kind of what probably most folks are most familiar with, especially if you've done any kind of like, even just like basic regression modeling or anything like that. You've probably run into something like this, where essentially you have your, let's call it your agent, and you have a set of inputs into your agent, and you know what the expected outputs for those inputs should be. So you know generally what your application or your agent should be outputting for those given inputs. So you have that ground truth. And then what you can do is you can send all those inputs through your pipeline, see what the actual output is, compare the actual output to your expected output, and then use those kind of actuals and expected values to calculate a bunch of different metrics here. So everything from your kind of standard precision recall, false positives, false negatives, and F1 scores, building confusion matrices like the ones you see down here. That becomes kind of a standard way that you can measure some of that performance. Occasionally, you'll be measuring or you'll be comparing actuals and expected values that are, say, like a text string, that because LLMs are these sort of non-deterministic tools that can output all kinds of different text, you might use something like similarity scores or Rouge 1 scores to compare how similar is the text that my application output to the expected text. Even though the wording might be slightly different, are they similar enough? Is the substance the same? And so there's some scoring metrics that you can do to actually calculate that as well too here. And then on the right, there's also the kind of similar approach of looking at metrics where you are comparing the distribution of outputs from your application to an expected distribution of outputs for that application. So instead of going kind of line by line of saying this output compared to an expected output, you're looking more at the overall distribution of outputs compared to an expected overall distribution of outputs. There's a whole nother presentation you can do on each of these metrics and diving into how it all works. It's a little bit more like traditional data science. But with this, the general theme of these evaluations is you have some sort of ground truth that you're comparing to. And so if you have that, great. And I think almost every production application that has observability or evaluation is using some form of ground truth evals here. But sometimes you don't actually have that ground truth data. Maybe you're just getting started. Maybe you haven't had a chance to collect that yet. And sometimes you're trying to come up with, or you're trying to evaluate things that are a little bit more qualitative, as opposed to this really kind of definable, okay, does this string match this string? And so that's where LLM-as-a-judge can help. And this is another area that we've focused a lot within Phoenix to build out. The way that LLM-as-a-judge works is by, as the name sounds, using a separate LLM to be the judge and the arbiter of your application's output. So to take an example here, what you would do for, say, a RAG pipeline is you have a query bringing in data from a user. Then you would have some context that's retrieved, and you would send that through your application, and then you would get to some sort of response at the end. Or really, you'd send the query into your application. It would grab the retrieved context, and then you'd end up with a response at the end. In this hallucination evaluation example you see on the slides, we'd take the query, the context, and the response, and we'd send them into a new template that you see down here, where we're saying, okay, separate LLM, based on this context and query, is the response hallucinated? Or is there anything in the response that's hallucinated? If so, label the execution as hallucinated. If not, then label it as not hallucinated. So you're using the separate LLM to make that judgment. And I think that's what I was thinking of. So something that we support within the platform to do this, and I'll show you guys an example of this as we go into the code. But basically, we have a whole library within Phoenix that will support running these kinds of things for hallucinations, for question answering, for relevance, or just for any other kind of setup you want to do. Hopefully, it's some folks might have realized that you can define what this template looks like here. So you can really use the LLM as a judge to evaluate almost anything. There's a lot of concerns, like caveats around like how to best use this, but you could use it to, like we've had people use it to evaluate the creativity of a response, We've had people use it to evaluate how funny a joke is in a response. And you can use those as kind of your indicators as you go through and evaluate your application. But you can really make that template whatever you want to make it. So you can set up all kinds of different LLM-as-a-judge evaluations as you go through. And one of the nice things too is that we also have some infrastructure in place to help them generate what you see here, this explanation on the side over here, where it'll actually also say, not just what's the label, is this correct or incorrect, is this hallucinated or not hallucinated, but also why did you choose that particular label? And so that makes it very helpful if you're trying to go through and read through, okay, why was this one hallucinated, as opposed to having to go through and look at the context that was retrieved and the response and try to like find do a little bit of like where's Waldo of where's the hallucination. The explanation field here will help you with that a lot, and that becomes very useful going forward. Normally I get a lot of questions right around this point of a couple things with LLM-as-a-judge. I think this framework or this idea will trigger some alarm bells for some folks. So I always like to add in a few caveats here as well too with LLM-as-a-judge. First off, to get this to work well, especially if you're using, if you're doing kind of more sneaky hallucinations or things that are a little harder to catch, you really do have to use some of the best models that are around. And when I say work well, what I mean by this is aligning with human labels and aligning with human responses. So if you look on the graph in the middle here, we've tested a bunch of different models. The black dots are human evaluations, like so sort of humans going through and labeling something as hallucinated or not. And then you can see the dots. When you can see GPT-4 follows the black dots pretty closely. Something like Llama 2, for example, is going to fall off a good amount and be kind of farther away from those. So you really do need to end up using either the largest models, or if you wanted to, and this is kind of going down another rabbit hole, but you can use fine-tuned models. So smaller models that are fine-tuned for a particular type of evaluation task. So like evaluating hallucinations. We've done some experiments fine-tuning, say, a 4.0 mini or some other small language models that have achieved similar performance to GPT-4 on the chart here. So that's one other caveat I'll add is you have to kind of be specific about the model that you're using to do this. And then the other big concern here is that if you do go for this approach, you are adding extra cost because you're making separate LLM calls. So there will be extra kind of infrastructure costs that you incur from that, or API costs, we'll say. So at that point, sampling gets really helpful. You can always sample your data and then evaluate some of that. But it also becomes a little bit more of a cost-benefit analysis of is detecting that better performance or detecting the bad performance and trying to rectify that worth the extra cost. And in most cases, we see companies will either come to that eventually or come to that immediately. So that's something to keep in mind, though, is that when you set up LLM-as-a-judge, you may want to sample data or you may want to go for a slightly different approach or be a little bit more diligent about choosing what kind of things you want to evaluate there. I'll say in most cases, in real world use cases, I see folks using both LLM-as-a-judge and ground truth evals side by side. All right. And then the last category I mentioned is sort of data set analysis. This is almost a different kind of evaluation in the sense that you're not really generating a label or a score necessarily, but it's just another technique that you can use to evaluate some of the outputs of your application. So there's a few things that are kind of encompassed into this, but the general idea is you can either spot check different responses or queries in your application and see if you're kind of noticing trends in your responses. And so one way you can do this is say you find an example where the user tries to jailbreak your application. You see a prompt that looks like a jailbreak prompt. What you can do is you can actually do kind of embedding similarity searches over your retrieved traces and say, okay, find me some similar prompts or similar queries from users and try to kind of collect your jailbreak attempts that way. Or similarly, maybe you've got a chatbot that is really bad at handling refunds. And so you notice that it's bad at handling a refund query. You then use embedding search or an AI search or something along those lines to go through all your traces and find you more traces that look like refund traces or refund queries from users, and then can kind of group things together that way. So in a lot of cases, this is kind of a combination of some human annotation. So within Phoenix, you can annotate different spans and say, okay, this was a frustrated user, or this was a refund requested, as you see an example over there. and then taking those annotated spans and trying to search through your captured traces to find similar traces to that. So it's another kind of technique that you can use to kind of go through some of the data that you captured through tracing. And then I'm actually going to jump over into the dashboard another time here, and I'm going to show you guys a fun example that we have in a model. So one other thing that you can do and that we supply is using other techniques to kind of explore the data that you're using or you're capturing with your application. And so this here is a technique that we have that is exploring some kind of basically using embeddings to explore a RAG pipeline. So similarly, this is a RAG pipeline that we set up. The pipeline itself is powered by Phoenix documentation. So that's kind of the corpus. It's the documents within our RAG pipeline. And then we've gotten questions about Phoenix documentation. And so you see all the gray dots that are on the screen here. All of those are individual documents within our corpus. So you can see like chunks from different Arize docs. You can see what some of those look like there. And then the teal is all questions that we've gotten from users. So in this case, we've gotten the questions, my monitor is noisy, how do I fix it? And you can see the question and the response. Now, if I zoom in a bunch here, you guys can start to explore this a little bit more. And I can see, okay, let me find one that renders well here. You can see those lines there where I've got my question connecting to the chunks that it pulled in that RAG pipeline. And what's really cool with this is that this is all mapped and created, this visualization, sort of with intent to show how similar different text strings are. So what we're really doing here is we're actually creating embeddings for each of these different chunks or questions, and then mapping them using UMAP into a 3D space. And so there's no significance of is something close to the middle, but there is significance of are two dots close to each other. That means those are two similar things. So by extension, what we can do is I can actually start to go here and say, okay, I've got this chunk of questions that are over here on the outside skirts. So you see this sort of thing right here. And those look like they're not actually near any other kinds of question or other kind of docs. So it's like this chunk of questions that are away from some of the docs that we have. So if I circle those and I kind of blow that up, I can start to see what some of these are. And so you notice that a lot of these questions are on the pricing of Arize and the pricing of our platform. And what's happening is that you see, like, unfortunately, I can't answer this question, or like we're not disclosing that information. No, we don't have a pricing calculator. That's all coming from the fact that we actually don't have like a pricing page in our docs. So the corpus of docs that are used for this RAG pipeline don't have information to answer this question. And so that's sort of represented by the fact that these are off on their own here. But we can use this UMAP visualization to essentially like zoom in on certain areas where we might be missing documents in our corpus. And we might want to add a document in because, hey, we're getting a bunch of questions from users about some of the information that we can't answer right now. So we would do well to add in that document. And similarly, we can do the inverse and say, okay, we've got these gray dots that are way up the outside here. Let me look at those and see, okay, these look like some kind of weird formatting things. And what these actually are is like random markdown tables and things like that are in our documents. And so this is because we've indexed our whole documentation. This is information that we maybe could drop out of our corpus. So if we wanted to be really streamlined, we could try to remove some of this information because it's way out here. We're not getting there's no teal dots anywhere near that. We're not getting any questions around that information. And so we could probably remove that from our documents. So this is another kind of technique that you can use. Again, it's sort of within the realm of evaluation because we're almost evaluating our data set. We're not generating labels for things or labeling something as hallucinated or not. But what we are doing is we're going through and we're actually able to kind of still identify ways to improve our application. And I'm showing here your kind of teal is your questions and then your gray is your documents. You could map other pieces onto this as well too. So you could always use other kind of approaches if you wanted to kind of map the different questions that you're getting based on time or something like that. You can use the same sort of way of representing things in 3D space across any other kinds of attributes that you have attached to your spans as well too. So this is a super powerful way to kind of explore your data and explore the traces that you have that are coming in. But it's something that is not always thought of when it comes to evaluation. So I was like covering this one as well. All right. If you guys have questions along the way too, feel free to throw them in the chat. So anyone has questions they want to dive into, we can go into those in a little bit more detail. But with that, I'm actually going to switch gears a little bit here and jump into a demo of the pipeline that we have. And so for this webinar, we've built a little bit of a demo, and I can show you a lot of those kind of concepts applied to a Haystack RAG pipeline, or sorry, a Haystack agent that has RAG as a tool. We've actually combined kind of the two pieces there. And so we've set that up to be able to work together with Phoenix and show up within Phoenix. So first off, everybody who's watching, give me a fingers crossed and prayer, because I'm going to do live running of all this code. We've got a backup if we need it, but hopefully we don't have any sort of breakages that come through here as we go. So I mentioned this is a pipeline that we have that is going to be a function calling agent set up using Haystack and then traced using Phoenix. So I've done some brief setup there to add in my keys and things like that. And then before I start doing anything with Haystack, what I'm going to do is just start up observability with Phoenix, which then means anything I do with Haystack after that point gets sent over into our Phoenix repo. I've already got Phoenix running locally on my machine. I'm just doing it through terminal. So I'm actually going to skip this step here. But if I wanted to, I can always run it kind of ephemerally in the notebook. It'll only last as long as the notebook is running, but that's one of the options we give for deploying Phoenix, along with running it locally on your machine or self-hosting it on Docker, or actually connecting to it through a cloud instance that we provide. So I'm going to skip this for now, but if you're just running this notebook, then you go through and run that. And then this is the code here that you guys have seen maybe a couple times now, where we're actually going to go through and I'm going to do two things here. One is I'm going to connect the notebook here using this register call we have. This is essentially connecting to that local instance I have of Phoenix. This is where if you were self-hosting it, you would specify kind of a different endpoint to send your traces to. And then I'm going to send everything into this specific project within Phoenix. And then the second piece I'm doing, talked about a couple times here, instrumenting Haystack. So I'm actually going to go through and make that call and then say, okay, now everything that we do with Haystack, we want to capture and send over to Phoenix. So at this point, like if you're making some other Haystack application, you're good to go. You can just start going and doing that, build anything you want in Haystack. Anything with pipelines will be tracked over and sent to Phoenix. So from here, you can kind of go nuts with your application and it'll all get traced for you, which is one of the really nice things about that auto instrumenter. I am going to keep going here. And so next thing we'll do is we're going to define an agent with some tools. We're going to do one of those tools is going to be RAG. And so what we've got here is we're setting up a Haystack RAG pipeline with just a few very basic documents. If you guys have been through some of the tutorials, you've probably seen this kind of thing before. And so if I go through and run that, let's see if that's going to be all good for me. And so one thing that you can actually see, as I mentioned, we will trace everything into Phoenix as well. And so if I jump back over here, and I'm actually going to open up our Phoenix instance, go back to our projects, and then if I refresh this, now we've got Haystack tutorials live. That's the project I just set up. And so you can actually see a couple calls already come through in setting that up. And one of them here is just generating those embeddings. So you can see that actually just generating the embeddings that we had is one piece here where that's going to get traced and tracked and sent into Phoenix as well, because that is calls that you're making to a pipeline to generate that information. So you'll see that that stuff already starts coming in. And then now I can flip back over and we'll continue building our RAG pipeline. And so now if I actually set this up, for anyone who hasn't used Haystack, this is going to define a pipeline for us with a prompt builder here, a few different components like an embedder and a retriever that are kind of some built-in things we're using to create embeddings and retrieve documents and everything like that, and then our LLM. And then once we add all those to our RAG pipe here, we're just going to set up some connections. So going from our embedder to our retriever, and then from that retriever to our prompt builder, and then that prompt builder to our LLM. And so that creates a full RAG pipeline that we can use from there. And now if I go ahead and run that, if all works correctly, we've got our response back. And then again, if I flip back over to Phoenix, you see we've now got a new entry here for our pipeline. So if I click into that, you can see we've got different components of the pipeline running. So we're generating an embedding for the user input. And then we're actually going to sort of store that or retrieve documents based on that. So you see some documents that we've retrieved. In this case, it's basically just pulling back all of our documents in this kind of simple retriever example. And then we're going to build a prompt out of those documents. So you can see we're building this whole prompt here that gets sent over into our LLM. So you can see this is the prompt that gets built in this output. And then that gets sent to an LLM. So you see, and then eventually it comes back with the response, Mark lives in Berlin. So even just there, that's kind of just tracing the very basic version of Haystack or of a Haystack pipeline. But you can see that this is one run through of our pipeline. And there's bunch of calls that get made there. If I was trying to go through and debug from there, then that would be something that's helpful to kind of be able to see everything that's happening from that. And then if I keep going down, we'll go through and we're going to do a few things here. One, we're going to turn this pipeline that we have now into a function that we can use that makes it easy to kind of pass over into our agent. There's a bunch more we could talk about of agent structures and things like that. So there's a bunch more information there, but generally for this, we're going to use a very straightforward agent where we have sort of a set of tools that we're passing to an agent, and then we're going to allow that to call those tools and choose one to go to, and then execute using that tool. So then we're going to define a second one here, which is setting up some weather info. So basically it can return some information about the weather. And now we have to do something. This is kind of a little more specific for how OpenAI likes to go about doing it, but we're going to define this tools object here, which has this specific format. This format is specific to OpenAI, so some other models will use it as well too. But basically, this is passing a bunch of information about the available functions that our agent will have into this tools object. And then you'll see as we go further down here and we set up a generator, we're going to pass in the tools into that generator so that OpenAI, when it chooses to, or GPT-4, whatever we're using here, or I guess 3.5 Turbo in this example, knows that it can call to one of those tools. So if it gets a question or an input that matches what that tool can do, then it will actually just say, okay, return a tool call that will go through and be able to kind of generate the output for the user. I see a couple questions that are coming in, and I want to just briefly touch on those before we continue going forward here. So one of them is around showing LLM-as-a-judge evaluation in Phoenix. I will definitely show you guys what that looks like as we go here. We're actually going to do that in this demo, so we'll cover that piece. And then there's a question around which LLMs can I use for evaluation in Phoenix, any open source ones. So you can use any sort of LLM that you want. You'll see as we go into the evaluation section that a lot of the way it happens is you're pulling information out of Phoenix, generating some sort of label for it, and then continuing on from there and uploading it back into Phoenix. So you can use a separate LLM. We have a lot of pre-baked connections as well too that make it a little bit easier, including one to Light LLM, which would allow you to do any sort of open source models there too. But I'll show some of what that looks like as we keep going too. And then there's a question around, can I store my prompts in Phoenix and evaluate the performance of prompts? So we actually, within Phoenix right now, within our open source tool, we don't have the ability to sort of store prompts in a prompt kind of hub or anything like that. It's something we're adding in the next couple of weeks here. So keep your eyes peeled. That will be coming in about a week or two. It is something that we have in the enterprise platform as well. If we have time, I'll show you guys what some of the kind of experimentation features look like in Phoenix. There's a whole area where you can evaluate different instances of prompts and different models and kind of run your application in a bunch of different formats and then have a sort of centralized place to test that and compare results. And so that might get towards the second part of your question if we have time to show it. Awesome. And then I will, and then I have one other question here, which is around okay, is there support for tokenizers? Some models don't return the token count in the response. Do you have a workaround for that? So that kind of gets into where you could take the auto instrumenter that we have, and you can always use that auto instrumenter, that one line call that we had before, that I'll just jump back up to here. Hopefully don't lose my place and show you guys. So this call here, this is great because it will kind of pull in all the stuff that you might be doing with Haystack, but you could use it in combination with some of the more manual tracing. So we have support for capturing tokens from most models that support it, but for those that don't, you could always calculate the token usage yourself with a tokenizer and then send that through as an attribute in what you're tracing. So you can always augment the stuff that gets automatically traced with your own information, like tokens would be one example of that. All right, cool. Great questions all around. Okay, so getting back to where we were here, we've got our generator that has some tools. I also will say I am a big Haystack fan, but I'm not necessarily the expert in everything in Haystack. So the Haystack team can also correct me if I've done anything wrong in here. I'm not using the most up-to-date components, so I apologize in advance if there may be better ways to do what I'm doing here. But essentially, what we've done here is we've said, okay, we're going to create a system message and then a user message here. And then we'll set up a little pipeline that has basically just a chat generator component to it that can then generate these sorts of responses from here. And so if I flip back over now, having run that with our "can you tell me where Mark lives" prompt, if all goes well, that will have shown up here. And so you can see it's just one basically call that's been made to say, okay, this is our system prompt that we had. Can you tell me where Mark lives? And then now we say, okay, it's coming back with this function call. So it knows that it could call that RAG pipeline function that we created with the query, where does Mark live? But we haven't connected this agent up to any of the tools yet. So this sort of stops the whole execution. This is all it does for right now, is just say, okay, we should call that tool. So the next step that we would then go into is saying, okay, let's go through and let's take the response from that and send it through this whole code block here, which will basically take the function call in that response. It will load through the different function name and arguments that are generated by our model, and then we'll actually call whatever the function is. And so now if I flip back over, we have another pipeline here where it's, in this case, we've like separately gone and triggered our RAG pipeline. So you can see the full RAG pipeline triggering again, same as before, embedding, retrieving documents, and then building a prompt. But those aren't connected yet because we kind of ran our one pipeline and we ran our second one here separately. So now if we go into kind of a full application here, this will actually connect all those different pieces. And there's a bunch in here that we could go through and kind of go line by line, but not too much time. So basically to kind of outline what I've done here is created we have our messages, our system message, and then I've taken that kind of tool handling code, put it into a component. And I think there may be a Haystack component that can do some of this for you. So I think that might be a little easier than what I've done here, but basically have a component to handle that tool response. And then I've also got my agent from before. So now I'm connecting the chat generator to a tool called handler that can handle that piece. And then eventually we'll come back and kind of give a response to the user. So if I trigger that here, and then I run our kind of chatbot with functions, so run that full agent, if everything goes well, you can see, okay, where Troilo lives, he lives in Rome. And if I jump over into Phoenix here, we've now got our first full run through of the application. And so you can see we've got that OpenAI chat call that we had before, choosing the function to call, and then goes to our tool handler here, which then goes into using the full RAG pipeline. And we'll expand this a little bit so you guys can see. You can see the full kind of RAG pipeline. This might look familiar from before here as we go into that tool call. And then you can also see back at the top, we've got our initial kind of selection of the tool. If you had a more complex agent, you would probably have this going back to that sort of initial tool calling stage where it might then go call other tools. You might have multiple kind of iterations through your agent. And this gets into kind of the idea of looping through an agent, where we're not going to necessarily show you loops in a kind of looped UI, but we'll show you the sequential view of that. So if you then went from this tool call handler and said, okay, we did the tool call handler, and then we go back to our initial kind of OpenAI call to generate tools, you might go back to that. You might go back to the tool call handler. You might kind of have these more in-depth execution structures as you continue going on through those pieces there. So you can imagine that depending on how complex your agent is, these can get to be decently sized traces, which are good, but it does mean that you kind of need some other way to parse your way through them. And so that's where evaluation, again, becomes pretty handy to do. So I know we don't have a ton of time, so I'm going to kind of hopefully show you guys some evaluation here. So now we've got our whole pipeline working. Let's evaluate a couple pieces of it. When it comes to evaluating agents, there's a bunch you could evaluate. You can evaluate every different step if you wanted to. And there's a whole another presentation you could do on how you break things down, which we have some material on especially as well. For this, we're just going to evaluate the RAG pipeline itself and kind of the relevancy of the documents that are retrieved. We're going to focus on that for here. And then we'll also do a little bit of evaluation of the function calling that our agent did as well too. So the way that I do that is I'm going to go through, I'm going to set Phoenix here, just kind of connect to our existing Phoenix instance. And I'm going to use a method here that's called get retrieve documents, which will pull out, if we see it here, it's going to pull out a set of documents that were retrieved. So these are this is a data frame of some information from Phoenix. You can see individual documents that were retrieved, the reference document itself on different calls within the application. And then if I keep going here, I'm doing a little bit of like data frame manipulation to kind of get some IDs in the right spot and basically get the input to be just the content from the user as opposed to some other stuff in there. So I've set up this data frame. And really all I need to do to kind of run evaluation with this here is I can just basically I need to get to a point where I generate a label column in this data frame, and then I'm just going to shoot that back up into Phoenix, and that will get some of the evaluation results into Phoenix. In order to generate that label column, we have a bunch of different libraries that can help with that. So this actually here is us using kind of a built-in relevance evaluator we have, just using it for a mini model, and then sending this data frame we have into our relevance evaluator to generate some responses there. And so just we're going to run a few different evals quickly with that. And this is using kind of, again, it's an LLM-as-a-judge technique here, using this built-in evaluator that we have to generate those responses. If you wanted to run evaluations some other way, you can totally do that. That's something that we wanted to make sure we support within Phoenix, is if you wanted to use a library like Ragus, for example, to do your evaluation generation, you can still do that and still use Phoenix as kind of your observability home. So we want it to be a little agnostic about how you generate some of the evaluation data. And so what you see now is we've got this new data frame where we've got our different documents. They've been labeled as relevant or unrelated. We've scored them just 1 or 0 based on that. And then you've also got that explanation text that's coming in here too. And so now I'll pipe those back up into Phoenix. That warning should be fine. And now if I go back in here, you might see some differences up here, which we'll come back to in a second. But as I start to click into my pipelines, I can see, we'll go into our main one here. If I jump back into kind of the retriever state here, where we retrieve documents, there's a bunch more information that we've now attached to some of those documents. So we've looked at we're calculating NDCG, we're calculating precision and hit rate for those. We've added all those pieces in through this relevancy evaluator. And we're actually adding this whole chunk here where we're evaluating every document that we pulled forward, and we say, okay, is this relevant? And then we just have relevant and score 1, 0. And then it has the explanation of why this is relevant. And then as you start to go down, you see some of the other documents that were retrieved. You can see they're unrelated. And then it has the whole explanation about why they're unrelated. In this example, it's pretty straightforward because it's basically just they don't have the right information that we need. And so this will be kind of captured in the individual span that you see here. And then we'll have more rolled up metrics for you up at the top. So you can see NDCG of 1 here. We've got a hit rate of 1. What that means is that for hit rate, every question we've had has had at least 1 relevant document. So hit rate is 100% of the time we've got a relevant document. But precision, which is a measure of out of the documents we retrieve, how many of those are relevant, is only 20%, because basically every time we've called our pipeline, we're returning all 5 documents and 1 of them is relevant. But in practice, this would give you a sense of if your precision is low, it means you're pulling up, but your hit rate is high, you're pulling a lot of documents, and you might be able to actually reduce the number of documents that you pull to just focus on the relevant ones, for example. So these metrics can start to guide you of how you want to tweak, in this case, your RAG pipeline, which is one of those tools of the agent. So that gives you some idea of how you can use some of the data there. And then really quickly, I know we're running a little bit short on time, so I'm going to quickly show similar kind of flow here for evaluating the function calling of the agent. Again, in this case, we're just going to extract some spans from Phoenix, and then I've done some kind of data frame manipulation to make them look a little bit prettier here. So basically, I'm trying to pull down each case where the LLM makes a decision on which function to call. And then in this case, I'm not going to use a built-in evaluator with Phoenix. I'm going to just manually define what that LLM-as-a-judge prompt would be. And so this is where I'm actually just writing out, here's what the LLM-as-a-judge prompt will be. And then it's going to get augmented with the available tools. And then for each row here is going to have the question and then the chosen function. And we'll say, okay, whether or not this is the correct function to choose. So let me find that. And then we'll run this through. Again, we're going to use, in this case, this is a built-in function with Phoenix to basically take that prompt and then take a data frame and run that prompt over each instance of the data frame. And there was a question before about using different models. So in this case, I've used this OpenAI model here. We've got some of these that are built into Phoenix, but you could use whatever other model you wanted to run these. At the end of the day, we're just generating, I think it's generated, we're just adding essentially like labels to a data frame. So if you wanted to do that with a different model or even just with pure code, you can do that as well too. And so then in this case, we're going to upload that back up into Phoenix. And if I jump back over, you'll see we have a couple new entries here. One is that each of our calls where we've chosen to call a function now have a tag attached to them. And if I jump into the feedback section, you can see, okay, this one we've done a function calling evaluation. It made the correct call. And you can see the RAG pipeline function is appropriate for answering the question about where people live. So in this case, we can see that it made the right call here. And then actually, if I jumped into one of these instances where we had the full run through of the application, and I went down to my LLM call, you see that we've also attached that to this particular span here as well. And then we are pulling all the results up at the top. In this case, we made the right decision twice within our function or our agent to call the right function. So hopefully this was a little bit of a whirlwind through the code. We'll make it available to everybody afterwards as well too. But hopefully this gives you an idea of how you can generate some of those different evaluations to attach to different kinds of pipelines or setups that you have to kind of not just trace, but also evaluate and give yourself some extra kind of indications of how your application is performing. We've got about 5 minutes left. So before I kind of wrap things up, would love to just take any questions if there's any others that folks have or that we had come through.
Thank you so much for that. Hope you can hear me properly. I'm actually going to start with a question from myself. This is more of a utility question. I noticed that like the first example you showed, there was tracing for the indexing pipeline where we prepare, chunk, and like get our documents in the right place. And then the other one was a RAG pipeline, and then we went into an agentic pipeline as well. Is there any way I can basically tell Phoenix what the name I want showing up is?
Yeah. So this is, it sort of gets back to, there was a question earlier where I mentioned something similar, but if you wanted to do that, there is a line that we could add, and it would basically be, I'll just show you in our docs because it's always easiest to see in there, but I've got it perfectly open here. So what you would do is there is a ability to add in, where are we? So it kind of goes to where you're splitting the auto instrumenter versus some manual instrumentation, but you can always use any piece of manual instrumentation along with the auto instrumenter. So all I would do is I would just, there's a call up here to get the, this call right here, get the tracer. You would just call that. That gives you the tracer object, basically. That's the thing that's doing all this collection for you. And then you would just go here and say, and you would wrap your, whatever your call is in this with, kind of start as a current span. And then you can change the span name here to be whatever you want. So you could relabel things, you could change it all up, do all those pieces. Yeah.
Gotcha. I do have another couple of questions lined up. I think you answered some of them on the fly, but if you like, we can go through the rest. And anyone who's still watching, if you do have any last minute questions, please add them to the comments and I can pop them up on the screen for you before we end this session as well. One thing that was a question, can we implement tracing for agents that invoke tools? We saw tools, but tools that are API calls, so not another pipeline.
Yeah, definitely. So you can do that. It would be a kind of a similar answer to this last one as well too, where depending on how you set it up, like with Haystack, you guys have a tool object that you would then call to. It sounds like you want to, right? You guys have.
Yeah, I was just going to say, because you're asking about how you can improve this example you showed. It was just 2 days ago, so you're good. Because 2 days ago, we released an experimental tool definition for Haystack pipelines.
Yeah, so assuming that I think our auto instrumenter will probably still pick that up depending on how you guys set that up. And if not, we'll add that. But if you were calling a tool through that, then we probably would already collect the traces for that. But say you had just like an external API calls, not related to Haystack or any other kind of framework, then you would basically use what we're looking at here, where you could manually add some instrumentation for that particular call if you wanted to. And the open telemetry is sort of smart enough to keep things in the hierarchy. So if you just start a span at some point in your application, unless you do a lot of work to get it as like a whole new trace, basically, so like a whole new hierarchy, it'll still be within that hierarchy that you looked at. So you can always use something like this to kind of do your own tracing. So if you have like a custom API that you're calling to that's not built in any framework or anything like that, you could still do that with this sort of approach.
Okay, so possible, but it may need some custom code depending on the situation. We should definitely explore the experimental tool edition then and see if that works out of the box. I think you also answered this. I remember you mentioning that you can't like show a loop UI, but is it possible to observe each step of a self-reflecting agent that then has self-reflection loops?
Yes, so we can show that. And I know we're running a little short on time. I'm going to very quickly try to show. I have a code-based one that I should make a Haystack version of as well. But just a pure code agent, I can show you what a little bit of that looks like. So if I've got, this is kind of a just purely coded agent. And let me see if I have a longer one here. So this is kind of what I was mentioning before of, say, we got an agent with a router and then some tools that we'll go through. This is what it would end up kind of looking like. So you got like a router call, you can see what it's doing. It generates, okay, we'll hard to see over there, but it'll generate the next function to call. It'll go through and do that whole tool. And then it's actually returning to the router and saying, okay, now I've got that tool response as well. It's kind of hard to read in here, but you can see it's got the tool message basically that came back from it. And then if I collapse that, it'll have actually it's probably easier to see here, sorry. So yeah, it'll see, okay, we've got first prompt, the assistant, the tool response, and then it would be the next kind of call from the agent there. So if you had a self-reflecting agent, you're kind of returning to the reflection step, and then it can see what the output of that reflection step would be. But yeah, we'll show that like linearly, so it'll kind of go down in this hierarchical view as opposed to like showing it in any sort of like loop UI.
Yeah, and I guess this is a good place to plug our session next week, because yes. Myself and John will be doing another session next week, this time hosted by Arize AI, where we're going to be talking about looping pipelines, agentic pipelines. So if you'd like to learn more about that, and I think I'll present how looping pipelines work, and then we'll also have a look into how you can trace them as well. I have one last question, and then I think we can slowly wrap things up. How is tracing and evaluating an agent different than tracing and evaluating a basic LLM app?
Yeah, it's a great question. Essentially with agents, there's extra steps that you'll end up evaluating. So you guys kind of saw, like in this example, we still evaluated the RAG pipeline. That was like one of the tools of the agent. And we used just a relevancy evaluator, but we kind of evaluated the RAG pipeline as we would a normal RAG pipeline, even though it's within an agent. So you can always do that with agents. You can evaluate the individual tools that they have and the performance there. But really the big difference is that you also need to kind of be evaluating either the function calling step that they have, so choosing the right function, extracting the right parameters to generate that function. And then the other big piece is, if you've got a looping agent, is it making progress? Like, is it converging to a response? And so that's the hardest thing to evaluate, and the biggest thing to try to do is like try to evaluate the execution flow of it. And the easiest way to start that is just like track the number of steps it's doing, track what each of those steps are, do it a little bit more manually, kind of like look through that and see. But yeah, if you have an agent that can get to a response in 3 loops, but it's doing it in 12, then that's also a big area of optimization. So that's a big thing to keep in mind too.
Nice. That's interesting, because we actually, because of this possibility, we have guardrails in place with Haystack where we define how many loops we allow, because yes, sometimes, depending on the model, of course, you can get stuck in a loop. And I think you added that to the event title, which is neat.
Yeah, definitely.
All right. Well, thank you very much, John, for doing this session with us. And thank you, everyone who joined. This is all recorded, and I think by default, it's going to be up on YouTube the second we end the session. But keep an eye out for next events and live streams, and see you all next time. Thank you.
Thanks, everyone.